Ahoy, mateys! The vast and mysterious ocean has always beckoned adventurers, explorers, and entrepreneurs. But did you know that beneath the surface of adventure lies a fascinating world governed by science, technology, engineering, and mathematics, the mighty STEM? From the ship's design to its navigation, from weather forecasting to cargo handling, STEM is the invisible force that propels the maritime industry. In this grand voyage of knowledge, we will explore the fundamental STEM concepts that underpin the maritime world. We will unravel the mysteries of physics, atmospheric science, mathematics, geography, planetary science, and computer science. Along the way, we will discover how these principles are applied in everyday maritime operations, making it possible for ships to sail across oceans, transport goods, and connect the world. So hoist the sails and adjust your compasses as we embark on this exciting journey into the world of maritime STEM. Whether you are a high school student dreaming of a maritime career or a seasoned professional seeking to upskill, this exploration promises to be both enlightening and empowering. This is about a STEM maritime program offered by www.edenboard.gr. Get ready to dive deep into the fascinating world where STEM meets the sea.
Before we set sail on the ocean of specific STEM topics, let's first dip our toes into the fundamental laws that govern the maritime world: physics. Physics is the science of how the universe behaves, from the smallest atom to the largest galaxy. In the maritime world, it helps us understand why ships float, how they move through water, and how to navigate the vast expanse of the ocean. One of the first things we encounter in physics is the concept of units. In the maritime world, the International System of Units, SI, reigns supreme. From meters for distance to kilograms for mass, understanding these units is crucial for communication and calculations. Imagine the chaos if one sailor spoke in knots and another in kilometers per hour. Next comes the intriguing world of forces. A force is a push or pull that can change the motion of an object. We experience forces every day, like the force of gravity pulling us down, or the force from our muscles when we lift something. In the maritime world, forces are everywhere. The wind pushing on the sails, the resistance of water against the hull, and the mighty engines propelling the ship forward are all examples of forces at play. Understanding these forces is crucial for designing ships, optimizing their performance, and ensuring safe navigation. But physics is more than just forces and units. It also encompasses concepts like energy, work, and power. These concepts are vital for understanding how ships use fuel, how much cargo they can carry, and how fast they can travel. For example, knowing the relationship between energy and speed can help determine the most fuel-efficient speed for a ship, saving both money and reducing environmental impact. Isaac Newton, the English physicist and mathematician, didn't just revolutionize our understanding of gravity while sitting under an apple tree. His laws of motion are fundamental to understanding how ships move and navigate the vast oceans. Let's delve into how his 3 laws of motion apply to the maritime world. Newton's first law of motion, often called the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. In simpler terms, a ship will not move until a force acts upon it, be it wind pushing on sails, engines churning water, or a gentle nudge from a tugboat. This law also explains why a ship in motion will continue moving even after the engines are turned off, only gradually slowing down due to friction from the water and air resistance. Newton's second law of motion provides a mathematical relationship between force, mass, and acceleration. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This means that a larger ship, greater mass, will require a larger force to achieve the same acceleration as a smaller ship. This law is crucial for calculating the power needed for a ship's engines, the force required for braking, and the impact of waves and currents on the ship's motion. Finally, Newton's third law of motion states that for every action, there is an equal and opposite reaction. This law is evident in the propulsion of ships. When a ship's propeller pushes water backward, the water pushes back on the propeller with an equal force, propelling the ship forward. This law also explains how sails propel a ship. The wind exerts a force on the sails, and the sails in turn exert an equal and opposite force on the wind, propelling the ship forward. Understanding Newton's laws of motion is essential for designing more efficient ships, optimizing their performance, and ensuring safe navigation. These laws are the foundation upon which maritime engineering and navigation are built, proving that even centuries-old physics principles are still very much relevant in the modern maritime world. We've all seen ships, some gargantuan in size, seemingly defy gravity as they float effortlessly on water. The science behind this buoyancy, the upward force that keeps objects afloat, was first understood by the ancient Greek scholar Archimedes. His principle, aptly named Archimedes' principle, explains why ships, despite their massive weight, don't sink to the ocean floor. Archimedes' principle states that the buoyant force on an object submerged in a fluid is equal to the weight of the fluid displaced by the object. This means that for an object to float, it needs to displace an amount of water equal to its weight. Shipbuilders use this principle to design hulls with a shape and volume that displaces enough water to support the weight of the ship and its cargo. Think of it like this. Imagine holding a beach ball underwater. You can feel the water pushing back up, making it difficult to keep submerged. This upward push is the buoyant force. The larger the beach ball, the more water it displaces, and the greater the buoyant force, making it even harder to push underwater. However, buoyancy is not just about the shape and size of the hull. It's also affected by the density of the water, which can vary depending on factors like temperature and salinity. Salt water, being denser than fresh water, provides a greater buoyant force. This difference in buoyancy is why ships float higher in salt water than in fresh water, a factor that ship captains must take into account when navigating between the two. Understanding buoyancy is crucial for determining a ship's cargo capacity, stability, and safety. It allows naval architects to design ships that can carry heavy loads without compromising their ability to stay afloat. So, the next time you see a ship gracefully gliding through the water, remember Archimedes and his principle that makes it all possible.